Next, we will see the main function can be called recursively or not. First, let's take a C file. Then we will take one example where we will call the main function recursively. Suppose your main function contains this statement: first I1, then you want to print the value of this I, then I plus plus, then you are putting one condition. If I equal to suppose 6, then there is return statement, then you are calling the main function. So this is your code. Your main function contains these statements. You are calling the main function here recursively. So what will be the output for this code? First, I holds the value of 1, then you are printing the value of I, then I plus plus, then I becomes 2 here. This condition becomes false, so this return statement does not get executed. Then this main function will be called, so the program control comes to this point again. Then again the value of I is 1, then it is printing 1, then I plus plus, then the value of I becomes 2 here. This condition becomes false, then again you are calling the main function. So let's see what will be the output for this code. First, compile it, then I am running this. Look, so what is happening here? It is printing the value of 1 repeatedly. Then after that, at the last, it is showing segmentation fault core dumped. So why it is coming? So I said that the data of the program or function is stored onto the stack. Stack memory is used for function calls. So whatever the data that will be stored onto the stack memory. So for this case, you are putting the value of 1 repeatedly onto the stack. Then after some point of time, the stack becomes full. So then stack overflow occurs. Then it is showing this segmentation fault error. So you can avoid this situation if you declare this variable as static. Static is a storage class. There are basically 4 storage classes. First one is auto. Auto is the default storage class. When nothing is mentioned, then that is auto storage class. Then static storage class, we will see the usefulness of static storage class. So if you, the main point is, if you declare one variable as static, then the initialization, this statement will be executed only once. And one more thing is, if you declare it as static, then it can preserve its last value. So next one more is extern. Extern storage class is used for declaring mainly global variables that can be used, that can be accessed between 2 or more program files. That means external program files can access that variable. And the last one is register. Register storage class is used for storing the variable onto the CPU register. It is same as auto. The main difference is It will store the variable onto the CPU register if the register is available. Register, you may know that it is one kind of memory. So these four storage classes are available in C. So for this case, if you declare it as static, then what will happen? First, the value of I is 1, then it will print 1, then I plus plus, then I becomes 2, then you are calling the main function, then for the next subsequent function calls, this initialization statement will not be executed. It is executed only once. So, and I can preserve its last value. So the last value of I is 2. So for the next function call, it will print the value of 2. Then I plus plus, then I becomes 3. Then you are again calling the main function. So then it will print the value of 3 like this. So it will print up to 5. Then when I become 6, then this return statement gets executed. So let's see. First compile, then run it. Look, this is the output for this code. It is printing 1, 2, 3, 4 and 5. Up to 5 it is printing. Then when I become 6, the function calls are terminated. So it is not like the previous case. So we will see one more example using this static storage class. Suppose there is one function print int a, then b, suppose 1, then b plus plus, then you want to print the value of a plus b, and here the main function contains this print I. You are calling that print function from the main function. So suppose you are calling this print function more than once, suppose 3 times. 3 times you are calling that print function from the main. So what will be the output for this code? You are printing first, what will happen? You are passing the value of I, that is 1. So for the first call, this a will hold the value 1, then b hold the value of 1, then b plus plus, then at this point b becomes 2. So it will print 1 plus 2, that means 3. So for the next function call, the value of I is 1, so 1 is passed, then b will hold the value of 1 again, then b plus plus, then b will be 2 here, so 1 plus 2, that means 3. So for every function call, it will print the value of 3. So let's see. So for this case, it will print 3, 3, 3. Now suppose if you declare this as static, then what will happen? So for this case, first, for the first function call, 1 is passed, then b, this b will hold the value of 1, then b plus plus, then this will print the value of 3 for the first function call. Then for the next function call, this statement, this initialization statement will not be executed for the next function calls. and as b is now static variable, so it can preserve its last value. So the last value of b is 2, so b plus plus, that means here 2 plus plus. So now b will be at this point 3, so 1 plus 3, that means 4. So for the next function call, this will print the value of 4. Then for the third function call, b the last value of b is now 3, so 3 plus plus, then this will print 1 plus 4, that means 5. So for this case, this will print 3, 4 and 5. Let's see. So it is printing for this case 3, 4 and 5. So this is the usefulness of static storage class. Extern and register are not so much used. So these are the case of static storage class. Now we will move to the pointers. So let's take a program file b.c. Next we will see what is pointer. So the first thing is pointer is nothing but a variable that can hold the address of another variable. So I repeat, a pointer is a variable that can hold the address or memory location of another variable. A pointer is declared like this in star a. So what does this mean? This a is a pointer to an integer type. That means this a now can hold the address of an integer type data. So suppose there is int b equals to suppose 5. So now this a can hold the address of an integer type data. That means suppose you are writing this statement a ampersand b. So what does this mean? A now holds the address of b. So suppose after this you are printing the value of b and star a. So what this will print? B holds the value of 5. So first it will print 5. Then star a. What does this mean? Star a. Star a means the content of the memory location that is pointed by a. So star a means the content of the memory location that is pointed by the pointer a. So that means the value of b itself. So this will print the value of 5. This will also print, this star a will also hold the value of b itself, that means 5. So now compile it. So look here, it is printing 5 and 5. So now if I write this statement b equals to suppose b plus 5. So now what it will print? B first holds the value of 5, then at this point b becomes 10. 5 plus 5, 10. Then it will print first 10, then what will be the value of star a? Star a, that means this a holds the address of b. So star a is the content of that particular memory location. Now the value of b has been changed to 10. So star a will also contain the same value, because the content, that means the value of b has been changed, so that will reflect onto this star A also. So this will print also 10 10. So like this. Now if I write this statement, star A equals to star A plus 5. Now what this will print? So here B becomes 10. Now this star A equals to star A plus 5. What will be the value of this star A? So what this will print now? So star A indicates the content of the memory location. So B has been changed to 10 at this point. So star A contains the value of 10. So now here star A becomes 10 plus 5, that means 15. So star A holds the value of 15. Now what will be the value of B? So B is also will contain the value of 15, because that is the content of that particular memory location. So if you change the value of B or star A, that will reflect on both. That is the case here. So for this case also, the change will be reflected on both. Look, 15 15. So if you change the value of B or star A, that will reflect on both B and star A also, because both indicates the same value. Both actually indicate the same value. So that's why the change is reflected on these two. So this is the use of pointer